Okay, let's go ahead and move forward with exponential and radical form today. So we're going to be talking about rational exponents, and we're going to just see that they act a lot like integer exponents. So some of the rules are the same, and we're going to be writing these monomials in exponent form and then also in radical form. So we're starting to look at some radicals. Okay, so let's go ahead and get started by just doing a little bit quick of a review in terms of simplifying. So hit pause. Go ahead and see what you can do with this problem. Okay, let's see how you did. So remember, this is a distribution. So we are going to take it to everything. So -2, 3 times 2 is 6, x, 5 times 2 is 10, y, 6 times 2 is 12, and 3 times 2 is 6. So z to the 6th. And these are not going to change. So I'm just going to go ahead and rewrite those. And then we're going to look at these in terms of separate pieces. Okay, separate pieces. So I'm going to go ahead and just draw some lines down here to kind of help me out. And if I remember correctly, when I'm dividing, I subtract my powers and it goes where the larger number is. Let's start with our z's. If there's 6 on top and 2 on the bottom, 6 minus 2 gives me 4. And there's bigger numbers on top, so there's a z to the 4. 12 minus 4 is 8. That number is on top. 10 minus 4, that gives me 6. And then I need to look at the 2's. So I need to remember that when I have any base, the base is not going to change. If this is -2 to the 6, that means I have 6 -2. So 1, 2, 3, 4, 5, 6. And on the bottom, I have 4 of them. And I know that the same thing on top and bottom means they're gone. So what am I really left with? I'm left with 2 -2's. Okay, so that would be -2 squared. Well, -2 times -2, that's +4. So I can simplify this to 4, x6, y8, z4. Okay, now I want to talk about one other piece here, which tends to be an issue for us, and that's this problem right here. So -y to the 5th power raised to the 4th power. So I need to remember that there is a -1 here. And it is a power of 1. So when I distribute, this is -1 to the 4th, and y 5 times 4 is 20. So the y to the 20 is pretty simple to deal with, but what about this? -1 to the 4th power. Remember, anything to an even power is going to be positive. So -1 times -1 times -1 times -1 gives me a +1. So that is positive 1 y20, or just y20. Now, if that would have been a power of 3, if I would have had something like this to a power of 3, that would be -1 to the 3rd power, y to the 15th. That leaves that a negative. Okay, so pay attention to your powers and to the coefficient that is in front of the variables. All right, let's start working on rational powers today. So one of the things that I really recommend that you either copy down or print out or have really close to you is this resource sheet. You're going to find this in your files and is attached to this assignment. This has all the powers, and we need the powers to help us with what we're doing in this chapter. So definitely either print this out or copy this down on a paper and keep this paper handy. We're going to use it all through the rest of the week. Okay, let's think about what happens when we see something like this. Let's go back and think about this. So this would be 2 times 3, which is x to the 6th. Well, what happens if I have x to the 1/2 power? What is that? What does the 1/2 power mean? Well, that is technically a radical. And the opposite of a square, so these are actually opposites of each other, is a square root. Okay, is a square root. And we call that sign a radical. It's not a division sign. Okay, it's not a division sign. It's actually a radical or a root. And what that means is we're looking for a base number. Okay, we're looking for a base number. So for example, if I said, what is the square root of 4? Well, that's 2. What's the square root of 9? Well, that's 3. So 3 squared is 9. 2 squared is 4. The square root of 16, 3 squared is 9. The square root of 16 is 4 squared, so the base is 4. We're looking for that base number, okay? So we're talking about radicals. Okay, so here's kind of the parts to the rational exponent. So we see that we have the opposite, the fraction is actually the radical with the power of n, kind of in this little spot, okay? So we need to kind of learn our parts of the radical so we understand what we're talking about. So the radical sign is just the big, funky, looks like a check mark with a line, okay? The index is the little number in between. And the radicand is the part that is under the radical. And that's what we're taking the root of. And we use this formula, the e over I, exponent over index formula, to kind of help us move from radical form to exponential form. So the e is the exponent or the power, and the I is the index. Okay, so the index is coming from over here, and the e is the power that is on our fraction, okay, or our rational power. Okay, so here we go. Let's start with taking a look at this right side and writing these as radicals. So I know I'm going to make a radical sign. This top number is my e. The bottom number is my I. So the 2 technically goes here. My radicand is the 25. So the 25 goes under the radical, and the power goes on the radicand. Okay, so this is technically the second power of 25 to the first power. Well, here's a couple things we need to know. We do not write the first power, so I don't need to write this 1. And I also do not write the power of 2 because this is known as a square root, which is a power of 2, okay? Which is a power of 2 or a 1/2 power. So we do not write the 2 in there. Now let's take a look at this next one. I see that the 1/2 power is only on the x. The 5 is really a multiplier. So this is really 5 times x to the 1/2 power. So 5 is going to be totally on the outside of my power. My radicand is the x. Remember, this is a 1 and this is a 2. Well, the best answer is going to be 5 square roots of 6, or square roots of x, because I don't write the 1 and I don't write the 2. Okay, let's go to this next one. So I have a 1 here and a 2 here. I need to remember that. So that's really 18 to the 1/2 power. So that's how I write that as a rational exponent. Okay, I write it in fraction form. Now this one, the entire thing, the entire radicand is raised to the power. So this needs to go in parentheses. Okay, that's different than the one right across from it where the 5 was not in parentheses. This is also to the 1/2 power because this whole thing is a power of 1 and a power of 2. Okay, let's look at some more. Let's see if we can come up with these. So hit pause, see if you can write these either in radical form or exponential form. Okay, let's see how you did. It's a power of 2, so I know it's just the square root of a. I have 22, that is to the 1/2 power. Now the 7w, that is a radicand. So the 7w is underneath, and I don't have to write another power there. Now this one, the 2 is on the outside. That's a multiplier. So 2x 1/2. Remember, this is a multiplier, so it is not attached to the 1/2 power. Okay, let's look at some that are not in powers of 2 to figure out how we're going to write these. Okay, so if I have x to the 1/3 power and I need to write that in radical form, well, the radicand is x. I know the power or the exponent is 1, and the 3 has to be there. So any power, any index that is not a power of 2 has got to be written. So the best answer for this would be the cube root of x, and that's how I say that, the cube root of x. Okay, what about this one? The whole thing, this is my radicand, so that is going to go under the radical. I see that's a power of 1. I don't have to write it, but that's a power of 4. So this one we say fourth root. So fourth root of 5y. All right, what about this one? So 64 with a 3 and a 5. So we know what our radicand is. What's going to go on top? Well, if I remember right, that's the e. So the 5 goes on top, and the index is a 3. So that is 64 to the 5/3 power. And this last one, 8. The 2 goes on top, the 3 goes on the bottom. So that would be 8 to the 2/3 power. And we're going to learn how to evaluate these as we move forward today. Okay, so here's where the evaluation comes in. So let's take a look at this problem. So we have 8 to the 1/3 power, which is the third root of 8. So this is where our power sheet is going to come in handy, because I'm going to be looking at my third root. Okay, so my power is of 3, and I'm going to be looking for the base number. Okay, the base number. And on this bottom one, 2 to the 4th power, I'm going to be looking at the fourths, and I'm going to be looking for the base number. Okay, so let's see how this works. So I'm going to go ahead and shrink this and pull up my power sheet so we can take a look at it. All right. We're starting with looking at a power of 3. So we're going to take a look at these first two problems here, which are both powers of 3. And specifically, I'm looking at this right-hand side. So I'm going to pull this over a little bit so that I can specifically see. I can specifically see my powers of 3. Okay, so here's what I want you to do. I want you to look at your powers of 3, and I want you to find 27. And I'm looking at the powers of 3 because that is a third power. Okay, so I'm looking at my powers of 3. So if I look over here, I see I have 27. I have 27 right there in the center. Okay, and 27 has a base of the 3. So I'm looking at the big number, the coefficient. Okay, so the base of that is a 3. So 3, the third root of 27 is 3. Okay, let's look for 64. So come down the right-hand side, find 64, come across. What's the big number? The base is a 4. So that is a 4. Okay, let's take a look at our fifth powers because we've got some 5s here. So let's look for 32. I see 32 right here. The base power, the base number, the coefficient is a 2. So that is a 2. And then what about our fourth powers? Well, I don't see 10,000 on this list. Okay, I don't see 10,000 on this list. So how can I use my calculator to help me evaluate that? Well, I know that 10,000, that this is actually to the 1/4 power. So I am going to put parentheses around that, and I'm going to open up my Desmos calculator. And I'm going to put that in. So 10,000. And I'm going to use my a to the b. And I'm going to go ahead and use parentheses here because since I'm doing a fraction, I really need to isolate all that inside that parenthesis. And if I hit enter, I see the answer is 10. So the base number of that problem is 10. Okay? Now let's see if we can actually do the same thing with this 32. I know that's 32 to the 1/5 power. So if I put in 32 and I raise it to a power, parenthesis 1 divided by 5, I get a 2. So that does work. Okay, but it's really important that we understand how to do these without a calculator because it's much faster if we just use our powers sheet, and we need to understand them and memorize some of them as we kind of move forward. There'll be some that we use all the time. Okay, let's keep going here. Let's get my power sheet back up. And we're looking at the third power of 125, and we're looking at fourth powers. So let me pull up the third powers first, and then we'll switch over to fourth powers. So here's my third powers. Okay, so 125, I see over here that I have 125. The base is 5. The base is 5, so that one's done. Let's do our other third power. Let's go over here to 27. Well, 27 is here. I see the base number is a 3, so it's a big number 3. Let's look at our fourth powers. The first number I'm looking for in my 4s is 1296. Well, 1296 is down here at the bottom. What's the base number? Yeah, it's 6. It's 6. And then what about 256? 256, the base number is a 4. It's a 4. And I didn't need a calculator. Okay, I didn't need a calculator there. I didn't have to type anything in. I just used my power sheet and looked for the coefficient that is attached to that power. Okay, so now we're going to actually put them together and have a fractional or something more than just a 1 on top. So let's go ahead and look at this one. Okay, so this 8 to the 2/3 power. So that's really the third root of 8 and it's squared. Okay, the third root of 8 squared. So, and I'm gonna write this a little differently, I think, to kind of help us see what's going on here. So 8 to the 2/3. My radicand is 8. My index is 3. And I'm going to go ahead and do this because I think it makes it easier when we are evaluating. So let's go ahead and get ourselves up to cubes here. So here are my cubes. I want you to find the cube root of 8. So when we're solving these problems, we work from the inside out, okay? So I want to find the cube root of 8. So what's the base of 8? Well, here's 8. The cube root is going to be 2. So the base is going to be a 2. So this whole thing is a 2. This 2 squared is going to drop. What's 2 squared? Yeah, it's 4. So my answer is 4. My answer is 4. And again, I didn't need a calculator. All right, what about these guys? Well, let's start with some of the easier ones. We'll come back to the 9 and the 100 in a second. Let's start with this guy. Let's write it in radical form. So the radicand is 36. My index is 2. So that means I'm looking for a square root. And I'm going to raise it to the third power. So let's go ahead and look at our powers of 2. Where's 36? Yeah, 36 is right there. The base is a 6. So I have a 6 here. And I'm raising it to the third power. So let's come across and look at our power sheet. 6 cubed is actually what? Yeah, it's 216. It's 216. I didn't need anything to help me do that. I just used my power sheets. All right, let's look at this third root. So the third root of 27, and I'm going to square it. So here's 27, come across. I see the base is a 3, so this becomes a 3, and I'm going to square it. So 3 squared is actually 9. All right, we need a fourth root. Let's go ahead and do this 256. So fourth root of 256. So let's write that out. Fourth root 256 to the fifth power. So 256 to the fourth power is a 4. So that base is a 4. And then I'm raising 4 to the fifth power. Well, 4 to the fifth power is 1024. 1024. Okay, now this fraction, since the whole thing is raised to 9 over 100, that means I have 2 fractions, okay? I have the square root of 9 raised to the third power, and I have the square root of 100 raised to the third power. So what is the square root or the second root of 9? Well, that's 3. Okay, so on top I have a 3 and it's cubed. Square root of 100, that's 10. So 10 cubed. So what is 3 cubed? 3 cubed is 27. And what is 10 cubed? 10 cubed is 1,000. And it works, okay? It works. Now, if I wanted to check myself on the calculator to see if I did it right, this is going to work exactly the same way. Let's go ahead and put this 27 to the 2/3 in there. So 27, and I'm going to use my parentheses, 2 divided by 3, and you can see how it gave me the answer of 9. Okay, so I can use the calculator. Don't really have to. Using the power sheet is much faster. Okay, so that's what you're going to be working on for today. As we move forward this week, we're going to be working on solving exponential equations, and that's where these bases come in super handy. So again, make sure that you either write these powers down or print this sheet out or something. You need to have these powers handy. Okay? All right, have a good day. Reach out to us if you're struggling.